Folks, as I mentioned earlier on, Prabhat is the head of engineering at DataStax. We talked about column stores the last time. These guys started off building Cassandra, which was one of the earliest column store families, column store systems. It did really well, especially when you had very, very wide tables with lots of columns. They had this concept of column families that we haven't talked about. But today he's going to tell us about something new and different at DataStax. So Prabhat, the floor is yours. Go ahead and share screen.
So my name is Prabhat, as Jignesh said, and I got to see some of you a few months back when I was there, and I'm looking forward to another session in person, hopefully next few months. That happens. It's always lots of fun to meet the students. Today I'm here to talk about little things that we do on our cloud product that has a lot of impact for our customers as well as for the company. So it may sound trivial, but you will see like how doing little improvement can have a bigger impact on the database offering that we do. So today I'm here to talk about Snapshot and the retention policy that we introduce on Astra DB. So what is Astra DB? So Astra DB is a database as a service product. So database as a service is like, normally, for example, if you want to use Postgres or if you want to use any other database like that, you're going to have the hardware, you're going to install the database, you're going to run it yourself. That's a lots of operational cost on the company that is running these databases. So the idea is that you use a cloud hosted product where companies like DataStax will host the database for you. We'll do the patching, upgrading, the backup, make sure that there's no data loss, make sure there's a security and things like that. All of this basically help you to offload your critical engineering, challenges to vendors like us. It allows you to focus on the business problem that you are solving, and overall DBaaS is often turn out to be like more cost effective for our customers. Now, Astra DB is a database as a service powered by Apache Cassandra, which is an open source database that has been used in the industry, especially with the big companies like finance, insurance companies, all those people. When you think of like JP Morgan Chase, Bank of America, all these people use our database quite a bit. So that's the DBaaS. To give you a quick look of what it means for our customers is that when they have an account, they will see something like this. When they create a database, they will choose a flavor of database. They will give something like a name. They will choose which cloud providers they want to run their database on, which region, and they will just create the database. And within 2 minutes, they will have a dedicated Cassandra cluster that's running for them, right? So it's that quick. Imagine doing that yourself on your like data center. It's gonna take a lot longer. So with that, so what at high level, every database has a read path, write path, and there are lots of like background information, background services doing the optimization. In Cassandra case, we have a layer called like coordination, which receives the request from the client application. That coordinator is talking to a bunch of readers and writers, which is responsible for optimizing the read path, and write path. And all the boxes are different microservices running on a different Kubernetes pod. So they are like very, very like is a disaggregated microservice architecture. That way we can scale the read path separately, scale the write path separately. And then the data, obviously there's some data stored on the disk, but every few seconds, the data will get flushed to the object storage. And that becomes sort of like our source of truth. Now, in this path as well, the metadata about data itself is just stored in a key value, a database called etcd, which is running on our infrastructure as well. So think of like coordinators, readers and writers, object storage is the main path, and with the metadata about the schema and things like that gets stored in etcd. Okay, so what is a snapshot in Astra? Obviously, all databases have snapshot capabilities because you want to give your users ability to switch back to the previous state when things go wrong. Sometimes our customers will accidentally delete their data, then it allows us to like recover by going back in the time. So, but in the context of Astra, the snapshot means the schema of the database and the tables that you have. created as well as the data. Now, so when we store the schema and the data, we have a JSON representation of a schema, which is stored on etcd. Then we have a JSON representation of all the live SS table. Obviously, I don't have time to talk about what those are if you don't know, but think of this as a segments of data that is stored in each file, right? And there's a reference to that file in our schema database, right? So when the compaction happens in Cassandra, when the compaction happens, we want to get rid of basically some of the SS table which are not being used anymore will get marked for deletion, and then later on the deletion will happen, right? So the more compaction you do, the more kind of wastage you have, right? So overall, that's what's happening. So when we take the snapshot, we obviously want to take the snapshot of the schema, which is stored in etcd, and the data as well. And when we're taking the snapshot, no data is actually moved. You still have the SS table sitting on the object storage. You still have the reference to those SS table on etcd, right? There's no actual, and then once the data is marked for deletion, because either customer deleted the data, or like a compaction process has consolidated different SS tables into one table, right? There's a background process which deletes the data. And this background process right now, before we introduced this feature, was like time-based, where it will take a snapshot every hour, and basically it will store those snapshots for like 20 days. What it means is that when we're doing at this frequency, which is like time-based frequency without any customization, there are like 480 snapshots for one database, right? So, and obviously we have like thousands and thousands of database. We're talking about managing lots of snapshot, which is a lot of like overhead on us, right? So what we wanted to fix this problem, because it was getting really, really expensive for us to manage that many snapshots, and not all customers were willing to pay for that, right? So what we wanted to do is that how can we be efficient about it, and how can we like delete it so that we do not hurt our customers' ability to like recover, like when something goes wrong, and it also saves money for us. So more snapshot, more obsolete SS table retained, space wastage, bigger cost on us, and the customers are not really getting any advantage because of this extra like snapshots, right? So what we came up with was the tiered and the time-based combination of that. So on the tier 1, the last 24 hours, usually what happens when you mess things up, you kind of know about the problem happened right away and you want to recover it. So on the last 24 hours, we basically take an hourly snapshots, and we retain a minimum number of days. That means hourly snapshots are only maintained for a day. But on the older one, we take the one snapshot per day, that way, and we delete the previous hourly snapshots, right? So that's why we have like a tiered like snapshot policy. So what this means, going back to that, is that for 24 hours you have like 24 snapshots, and for the last 20 days you just have like 20 snapshots. So you have gone from 480 snapshots to about 24 plus 20, like 44 snapshots in total, which is a huge difference, right? So to give an impact of this one, this is for one of our customer. Before we enable the snapshot tier retention policy, they were only paying for like less than like few hundred terabytes of data, but we were paying our cloud providers for 2.8 or 9 petabytes of data. When we enable this thing, as you can see, the total bucket size for that customer went from 1.5 petabyte to 497 terabyte, and we actually deleted almost 6 million SS table. This is not only saving us time on the storage of those data, but it also saving down the extra all these background processes that is doing compaction, the cleanup, things like that. All of a sudden they have less 6 million less objects to like clean up. But then that means it goes.
But we'll need to wrap up. The next class is already starting to stream in.
Yeah.
Sorry.
Okay,
I messed
so
up.
that was my presentation. I'm happy to take question.
That's great. Wonderful. Let's give him a round of applause.
Thank you.
I have one quick question. So obviously, we'll talk about snapshots and stuff later on in the semester. And Prabhat, maybe just like 20 seconds. Do you back up the snapshots? Like, do you have replication of the snapshots? Or what's the fault tolerance on the actual data of the snapshot that's stored on disk?
Yeah, so our customers have two kinds of data. They could have all their database in one region on one region, and they could have a multi-region databases. So if they have the multi-region databases, then the snapshot will get replicated across the region as well, right?
Great.
But if it's a single region, then it's only on the one.
Awesome. Great. Thank
All right.
you. Appreciate
All
you
right.
coming over. Thanks.
Thanks. Bye, guys. Have fun.